Okay, so back in section 4.1, somebody asked me, what are we going to use these antiderivatives for? And here's our first example. Number 53. A ball is thrown vertically upward from a height of 6 feet with an initial velocity of 60 feet per second. How high will the ball go? What do we know? We know the initial height. So the initial height is 6. So starting height is 6. Start on a clean piece of paper here. So starting height equals 6. What else do we know? Starting velocity told us was 60 feet per second. That was 6 feet. We want to know how high the ball is going to go. What do we do? We have to account for gravity. So on planet Earth, what's the acceleration due to gravity? Negative 9.8 meters per second squared, but we're working in feet. Negative 32. So we know acceleration is negative 32 feet per second squared. How does that help? Well, we take the antiderivative. If I take the antiderivative of acceleration, what am I going to get? Velocity. If I take the second antiderivative of acceleration, what am I going to get? Position. So if I take the integral, because remember we had this before, if we had position, we saw that the derivative of position was velocity, and we saw that the second derivative of position was the derivative of velocity, which was acceleration. So in these problems, basically we're going to work backward. We're starting with, we know what acceleration is. So if I integrate once, I'll get velocity. What's the antiderivative of negative 32 dt? Except we're not using x, we're using t. And that's part of what this little dt is. Plus c. Excellent. So we hadn't really answered what this dt is here for. But part of it is, in a problem like this, it tells us our variable is t. So if I give you the antiderivative of negative 32 dt, you should tell me negative 32t, not negative 32x. So this is negative 32t plus some number c. Now what do I do? Put 6 in for c. Close. How would I put 60 in for c? Why should c be 60? Because this is velocity. So, starting velocity, this is another way of saying v of 0 equals 60. So if I plug that in, I get 60 equals minus 32 times 0 plus c, which tells me c is 60. So my velocity function is negative 32t plus 60. So that's starting velocity. Instead of using plus c for these problems, quite often, they'll write that symbol. They'll write negative 32t plus v0. They won't use c, they'll use v0 for starting velocity. All right, now what do I do now that I know my velocity function? Antiderivative to find my position function. So s of t is the antiderivative of negative 32t plus 60 dt. What's the antiderivative of negative 32t plus 60? Negative 16t squared plus 60t plus, I could use the letter c, but I don't want to. I want a better letter. It's the starting position. And in this case, the starting position is 6. So we have s of t is negative 16t squared plus 60t plus 6. All right, so there's an example of where you use antiderivatives. If you start with acceleration, you can do the antiderivative twice in order to get your position function. Now, how are we going to determine how high the ball goes? Plug what in for t? Not 0. If I plug 0 in for t, I'll get 6, which tells me that's how high the ball started.
I would just, check the derivative of
Solve what for t? I'll give you a hint. This is not a calculus question. How do you find how high the ball went?
Foil.
Not foil.
Reverse foil.
Not reverse foil. So what equal to 0? No, that will tell me where the ball hits the ground. If you graph this, what kind of picture would this be if you were to graph it? Parabola. Does it open up or open down? Opens down. How do you find the highest point on a parabola that opens down? You find the vertex. So the question is asking you to find the vertex. T equals negative b over 2a, which is negative 60 over negative 32. So that's how long it's going to take. So t is going to be negative 60 over negative 32 seconds. I should reduce that fraction. How can I reduce that fraction?
16. Why is it 36?
Because it's negative b over 2a.
Yes, okay.
15 over 8. I can reduce top and bottom by 4. So it's going to take 15 over 8 seconds for the ball to reach its highest point. And then how would I find its highest point? Plug that in. So I'm not going to finish that off. You can grab your calculator. Take 15 over 8, plug it in, and see what you get. Questions on that? Okay, so there's an example of what antiderivatives are used for. And I would hope you would believe that we're going to do a lot more with antiderivatives as we move forward. Nah, we won't. Just do them for fun then. Okay. Questions on that one?
If you were to give this question on a test, would you expect us to know how to find the vertex? Or would you give us that negative b over 2a?
I would expect you to know how to find the vertex. Because you could do it using calculus. Correct?
Yep.
The vertex is the maximum. How do you find the maximum? Take the derivative, set it equal to 0, and then use your critical number. So if you didn't remember your pre-calculus stuff, you could find the maximum doing calculus. Now, this brings up a wonderful point here. If I were to take the derivative of negative 16t squared plus 60t plus 6, what would I get? I would get my velocity, negative 32t plus 60. And then how would I find the critical point? Set that equal to 0, and what would you get? Same thing you got. So in a problem like this, asking where does the ball reach its maximum height is the same as saying where is the velocity equal to 0. Because when the ball goes up, and then it reaches its highest point, it actually stops just for an instant, and then it turns around and comes back down. So if you didn't remember the negative b over 2a formula, you could use that. And notice if you take negative 32t plus 60 and solve it, you get exactly negative b over 2a. And that's really where that formula for the vertex comes from. That formula for the vertex comes from the derivative. Other questions?